My lords, ladies and gentlemen, it's a very great pleasure and an honour for me to be standing in front of you as the President of the Institution of Chemical Engineers. It's also somewhat of a surprise. My relationship with the institution goes back 40 years and, to say the least, has been interesting, and this is perhaps the most interesting moment. But I will say something more about that later on. I wanted to begin by talking about this shield, which is shown here, because it describes, in the way only the College of Arms can do, chemical engineering as it was seen when devised in 1964. And I'll just point out a few of the things. This is a cascade here, of which all chemical processes were assumed to include. The salamander on the bottom left is a symbol and a name for a crucible in chemistry, and fire associated with it is an obvious reference to heat transfer and heating. And then finally, and perhaps most importantly in a way, this is a mill rind which is associated first of all with milling corn, which it is argued was the first continuous process. Now you can believe all those things if you like, but I think the most fascinating one are these two integral signs at the top, which are associating the discipline of chemical engineering with mathematics, which is, of course, a very strong and continuing association. So if that was the view in '64, I think you have to think now it is quite different. And that's what I want to talk about, not the differences so much in what is happening in the world that chemical engineering serves, but actually its consequences for the institution. I want to pay tribute to Des King, my immediate predecessor, for his splendid leadership of the institution over the last year, and to many people before that. And they have most recently concentrated on the development of the institution's remit, the recognition of new aspects of chemical engineering, both in the UK and, more importantly perhaps, in the whole world. What I want to focus on is to build on that, but talk about how the institution needs to respond. And I believe there are a significant number of changes and challenges for the institution because of those developments. The challenges for engineering in general, you could even say for humanity, are often cast in these four terms, and particularly in the roadmap for chemical engineering futures. Those are identified as four key challenges. And then there are a series of issues and concerns for chemical engineering that we need to consider. And of course, everywhere there is a node in this diagram, there is something to be done, something quite substantial to be done. Among these concerns, I think we obviously recognize we want to do everything we can that is safe, sustainable, but I want to pull out two words from this. One is multidisciplinarity collaboration, one phrase, and the other one is systems, and particularly the systems approach that characterizes much of modern chemical engineering. That, I think, is a unique feature of chemical engineering, and it is essentially my basic proposition that chemical engineers are among the most promiscuous, the most Catholic in their interest in working with other people and solving these problems, compared with any other discipline. They spread themselves widely. The discipline has spread itself over the world in a very effective manner, but each step has caused the institution some new challenges. And I think I want to express most of those challenges in terms of balances between various competing forces. And I'll try and do that as I go through what I have to say. I think I should probably give you my own personal perspective first, and I want to do that by talking about the pipeline through which the traditional chemical engineer, beginning as a first degree entrant, perhaps these days through being interested through a lot of activities that are joint across all of engineering, and indeed more generally across all of science, the Big Bang, E for E, particularly around ChemEng, why not chemical engineering, the on-campus activity, Get Chartered and so on, all of which bring more students into chemical engineering. And I think we recognise that chemical engineering undergraduate courses in UK at least are now roughly at saturation. There are very few places which can still absorb more students. So I think a very successful beginning to the pipeline. And on the way through, people go through these various stages of membership of the institution, perhaps eventually ending up as chartered members and fellows. What I am, though, is one of these people on the outside of the pipeline. It's somewhat ironic that the institution was forced to move its venue for this activity from the Institution of Chemical Engineers to the Institute of Physics, where I have been a fellow for rather longer than I've been a fellow of chemical engineering, having begun life as a physicist. I'm no more popular here, of course, because I've done a number of reviews of physics that have got me into trouble with a whole series of people, particularly those in particle physics and astronomy, but no more of that here. But my journey is therefore not that straight down this pipeline. I somehow crept across the border of this pipeline. And of course, we should also speak about people who escape from this pipeline. They begin on this route, but transition outwards. If you teach inside of a university, at least it has been my belief, you do not mind that. The process of educating people in the university is about educating them for a transient activity which will change dramatically through the 40 years of their working lifetime. They may start off as one thing, but by the time they have finished 40 years of work, they will have done many other things. They reinvent themselves. And what a university education is about, supported by institutions, will be around training for that journey through life, which may not be down this single pipeline. We also, though, as an institution, need to care about these people who perhaps contribute to the evolving nature of chemical engineering as a discipline and its activities, but haven't always found it easy to transition into the discipline. So here's my journey very quickly. I began as a physicist, worried about the forces between the simplest possible molecules. In fact, even argon was quite complicated for us. And after training in this country, I went to the United States and started, I met engineers for the first time and decided or discovered that what I was doing could be useful. And that was a bit of a shock as a physicist. In fact, somewhat depressing. But nevertheless, this step of designing instruments to measure the properties of fluids was a key step. It was a key step in two ways. First of all, it enabled us to go backwards to these properties, but it turned out, and this I had not recognized, that these properties were of interest to chemical engineers in the design of plants like this. The viscosity, conductivity, thermodynamic properties, all of interest. So when I came back to the UK, it was perhaps reasonable to join chemical engineering at Imperial. And soon afterwards was my first interaction with the Institution of Chemical Engineers through a thing that was then called Physical Properties Data Service, operated by IChemE and subsequently operated in conjunction with National Engineering Laboratory. At Imperial College, we were much engaged in this, and I began to understand the totality of the chemical engineering activity that represented, for me, the use of what I was doing. Now, there was a pure coincidence behind the fact that EPSRC, or SERC as it was at the time, stopped funding work into this because we'd solved that problem, and they rather more interested in doing this. So this is my route into chemical engineering. It was a research-based route originally, but of course at the same time I was teaching, and I was slowly allowed by Roger Sargent, who was then head of department, and Henry Savastowski to teach chemical engineering, at least in the first 2 years. I couldn't really do much damage there, could I? And I ended up, because of the design of these instruments, I did know a little bit about fluid mechanics, although Stephen Richardson, who's here, might disagree, and try to implement some of those things. So that's my route. Very strange route, you might think, but I think not so uncommon now. In the 70s, it would have been quite an unusual route, but I think it's becoming increasingly common. And I want to explore why that is and the consequences for the institution. So in many diagrams, you'll see this pivot with a balance of different kinds of people, because the institution is responsible for servicing what I think is a growing number of people, a greater membership of ever-increasing diversity. Diversity in what they do and where they come from. And it's my belief that that poses significant challenges for the institution, because the last thing we would want to happen is that some people fall out of our institution because we cannot contain them within a broad enough church. And for me, that's quite a significant challenge. You can think of many areas where that might happen, where there could be a fragmentation of the totality of what chemical engineering now embraces. Because the membership is growing very rapidly. I'll say something about its characteristics later on, but you see it has now reached 32,000 worldwide, and the growth is increasingly rapid. At the same time, its turnover is increasing even more rapidly, because, of course, the institution is much more than merely servicing its membership. It is about organising conferences, organising events, continuing professional development, and servicing a corporate and individual membership base. So quite a significant operation, again growing very quickly, doubling in the last 20 years, roughly speaking. The breadth of chemical engineering, as has been explained in several presidential addresses in recent years, is ever more increasing. It is a feature, I think, of chemical engineering that it bridges engineering and science rather more effectively than many other engineering disciplines. It's also able, I think, to contribute to many of the improved qualities of life, and we saw in the earlier roadmap just how that operates across the sorts of things chemical engineering does. And here I want to draw out another word, which is process, to add to the systems approach, because I think it is really the chemical engineering ethic of understanding processes that is dominant in modern chemical engineering, and also allows the modern chemical engineer to apply their expertise to processes other than chemical engineering. And to illustrate that, you will see here what people think and state their employment is now compared with how it was in the past. So if you look at the top line, you see the description chemical engineer has decayed dramatically from 23% of people describing them that way to 2% now over 50 or 60 years, whereas process engineer has gone the other way dramatically. So many more people now either think of themselves or are employed as process engineers and not chemical engineers. An interesting other sidelight is the third line here, chemists. I think you should interpret this probably as industrial chemists, not necessarily any other kind of chemist, where that was a common title in the 1940s, 50s, but now has decayed to zero. Rather few people responding to this survey describe themselves as industrial chemists, and that's a big change. And finally, just because it's somewhat amusing, you see the rise and fall of people describing themselves as managers. I probably shouldn't make any comment about that. All other things stay roughly constant here, particularly consultants and educators and so on, and perhaps that's not too much of a surprise. So there's something about the change in the makeup. But of course, chemical engineers are immensely successful, but not necessarily in chemical engineering. Here are examples of a few people. Ambani is the head of a very large chemical operation in India. Jerry Bouchek here is the President of the European Parliament. He is a chemical engineer. Mohammed Al-Mahdi is the head of SABIC, which has taken over much of the activity of ICI in some parts of this country, and is a very big chemical company. He is trained in US. Maxwell Richards is the president of Trinidad and Tobago, and he did a master's degree at Manchester and has gone back to his company and then onwards into politics. And finally, but perhaps most significantly, this is the current vice president of China, and likely to be, if you believe political pundits, the future president. And he is also a chemical engineer. So it is obviously a profession that leads to the top in many areas, and I do believe that to reflect the nature of the educational process that chemical engineers enjoy. There's one more person. Now, you might think Steve McQueen is not really a chemical engineer, and indeed that's true. But this is a clip from a very well-known film called The Great Escape, and for those of you who remember it, the first time Hiltz gets thrown into the cooler, he is throwing a baseball against the wall, and his small neighbor next door asks him what he did at university. Was it physical education? And Hilt's response was, no, it was chemical engineering. I think as a profession we haven't exploited that single phrase quite as much as we might have done. But aside from the people who have used their training of chemical engineering, I want to emphasize the breadth of the discipline, because the biodomain is becoming increasingly important to the discipline. I'll show you a little conflict later on between that and the way people are reporting themselves and where the institution sits. But I think we, sitting here, probably all believe that the biodomain, in various forms, various colors of biotechnology, meaning related to health, related to energy, all those different forms of bioactivity, could be very, very important in the future and will broaden the discipline very considerably. It'll be important, for example, in biofuels and biorefining, industrial biotechnology, and the size of the market is, of course, enormous. This particular drug, on which I am dependent along with many other people, I suspect, is Lipitor, and it has a very significant sale as one of the statins at the moment, and is, of course, the product of biotechnology. That's one dimension. But within that, you can look at very significant new developments. For example, the second and third generations of biofuels will be significant. I, along with Ron Oxborough, who I'm delighted to see here, were most upset by the failure to understand thermodynamics in the first generation of biofuels. But by now, people do seem to have understood it a little bit, and there is some hope now, particularly this example from British Sugar, which involves, of course, many chemical engineers, producing significant amounts of bioethanol by fermentation and distillation. The life cycle analysis is all there, the complete thermodynamic analysis. And of course, if you combine it with the production of sugar, then you can significantly reduce greenhouse gas emissions compared with the generation of an equivalent amount of fossil fuels, petrol particularly. And here's the sort of thing that's going to be used, 300,000 tons per year of waste material, thus not conflicting with food. It'll deliver combined heat and power of 580 gigawatts and several applications, including this hydrogen grid. And then finally, the biochar produced in this system can be used as a means of carbon sequestration into the soil. That's a system for me, and it is a prime example of how individual components are involving chemical engineering, but also the complete system. And I want to choose one more example because this is a very interesting example to me. It won a prize at last year's awards ceremony, developed in India by people from Queen's Belfast. Talks about removing arsenic from the groundwater in India without any chemical intervention. The trick is to use a lot of air here to produce aerated water and thus drive the bacteria that make it unsafe, because they're reducing bacteria in the ground as they stand, to make them oxygenating and oxidizing bacteria, and thus remediate the groundwater. And of course, that means this system needs essentially no maintenance and is continuous in its operation. Now, all those things are very different from the traditional view of chemical engineering based on an oil activity. And I think that is going to be the future of the discipline. It will be an increasing component. But it'll be one example of a balance to balance that new activity against the traditional. I'll show you later that the traditional activities are still dominating employment in the sector. And yet, we know we have this growing piece coming at us. Many of those new pieces will involve disciplines not chemical engineering. So particularly you'll have biologists, material scientists, mechanical engineers, all of whom will be engaged in the chemical engineering endeavor over the whole system. So we need to work well with them and embrace them. And there are interesting questions about how you might do that. Now, actually, what does the profession look like at the moment? Well, we have asked in a recent survey last year where people are still employed. And if you look carefully at this and you look back 10 years, it looks absolutely identical with 10 years ago. No change. The dominant element is still oil and gas, chemicals, consultancy, oil refining, and you see how many of these activities relate to the oil business. Not surprising. And of course, the nature of the oil business is changing to make it more sustainable, less carbon generating, and so on. But that is still the dominant place of employment. And yet we as the institution know that we are going to face a changing balance in the future. So we've got to be ready to respond to that. You see it's not till down here, you get to pharmaceuticals, you then have water, but still petrochemicals, food and drink, and so on. The power industry, which is becoming ever more important, I think, is still a small employer of our membership at the moment. But I expect that to change dramatically, and the institution will need to change to absorb it. The other change that's taking place is not everybody who enters this pipeline is now seeking to end up with chartered status. You'll see that the population of chartered members as a fraction of the whole membership, which is itself growing, is declining. That speaks to an increasing number of people who are doing different activities than would lead to chartered engineering status. So another change in the pattern of our membership. It wouldn't be reasonable of me to admit another changing pattern, and that is the gender profile, with risk of embarrassing at least one person here. This is a photograph of the Imperial College undergraduate class of 72, and I draw your attention to the person in row 3, 5th column here, which is Judith Hackett, now chairman of HSE in her earlier guise. The point I want to make is not that, but how few women there are. I think in this year there were 6. When I joined Imperial College in 71, I think there was only 2. 2 began and I think only 1 finished. How is that looking now? Well, in about 1990, we at Imperial College celebrated, bizarrely by having this photograph taken, having 25% of the intake female. That was, for us, a tremendous achievement. You might wonder why I've got my eyes closed in this photograph, but I refuse to say anything about that. But it was a significant milestone for us. For those who do know Imperial College, this, I think, is Claire Adjuman here, who is now a professor in the department. So that's an interesting record. What does it look like now? Well, this is just a part of the Imperial College intake of 2006, and you see a significant change in the diversity. First of all, around gender, of course, and secondly, around ethnic origins. But the other thing is, I can only show you here part of it, and that's because the number intake now is nearly double what it was in 1970, perhaps even more. And that's a very significant growth in the activity. But most especially, the diversity of the course reflects the diversity of chemical engineering, both in ethnic origins and gender. It wouldn't be right either if I didn't say a little bit about the balances struggled with by academia, not just in chemical engineering, but perhaps especially in chemical engineering. Since I know Leslie Thompson's here from EPSRC, and I have been a council member of EPSRC, I can say that the Research Council has been driving ever more towards rather more strategically based research and rather less bottom-up driven research. However, that has to be balanced. You cannot go all the way to one way or the other. And I think that's a rather important balance for the academic community. But it poses significant problems because, of course, the immediate benefits to industry on the bottom right here through pilot plants, or actually the research laboratory, or the teaching, are all balances with which the academic community has struggled forever, continue to struggle. It is increasingly difficult, I think, in the research dimension because of the way the Funding Council behaves and the behaviour of the research assessment exercise. That drives particular behaviour at the expense of other pieces of behaviour. And I think that's rather unfortunate, and I hope the new research evaluation framework will do something about it, but I'm not supremely optimistic, I have to say. The other balance, I think, for academia is around the balancing of the teaching activity and the periphery of where I think much of research in chemical engineering particularly now is. If you look at the balance between those two things, the typical core syllabus for chemical engineering would look pretty familiar to all of you. Heat transfer, separation, fluid mechanics, thermodynamics, all the things with which you're familiar. But the research agenda often looks quite different. And I could choose individual institutions and give you examples of that. There is a relationship between these. However, if you wish to do well in a research model of the UK particularly, then you need to concentrate on things like this, which will bring peer review praise and indeed RAE money. And that may be recruiting people who are stars in these areas. Are they also able to teach effectively in these areas is a slightly different problem. And I think therefore for academic departments there will be a problem of balancing growth in research at the periphery with the need to teach the core materials upon which the discipline depends. And the last balance, I think, is around the globalization of the world, which of course in chemical engineering has been especially profound and continues. This gives you an example of how it continues. This is taken from the last 3 months. The left-hand side shows you announcements of new projects, numbers of new projects, and you see most of them are taking place in the Asian Pacific region, rather few in Europe, even in North America. Whereas, on the right, you have the announced plant shutdowns for other reasons other than maintenance. And you see there, it's rather the other way round. A rather large number in Europe and a rather small number in Asia Pacific and other parts of the world. So the heartland, the core of chemical engineering activity as it was known, as it was exemplified in the Shield perhaps, is moving out of Western Europe elsewhere in the world. And IChemE, properly, stimulated by presidents before me and the institution, has responded to that. But it doesn't come without some cost. And it doesn't come without some challenge either. As you've heard, the institution is positioned globally. It has offices and activities in all of these cities, London and Rugby in this country, Singapore, Shanghai, KL, Melbourne, and Wellington. It is active in all those areas. It has members in all those areas. And I just wanted to look at a bit of history here. At the 25th Annual Associateship Membership, which is examination at the time, in 1950, there were just 1 candidate from Australia, 12 from Holland, 5 from New Zealand, and 1 from Trinidad. And out of the 118 candidates, 77 satisfied the conditions, and just 16% of candidates for membership, corporate membership, were outside the UK. Now, in applications, 27% are domiciled outside the UK, and of the total membership, 40% are now outside of the UK. That's a very significant shift and a very big challenge for the institution, to which it has been responding and will respond. I thought these were quite amusing recollections from the past. Dudley knew it in 1950. In contrast to today, the annual general meeting and the extraordinary general meeting lasted so long that it was possible, and indeed deemed appropriate, to send out the presidential address by post. I have to say, we are being videoed now. It is going to be streamed on the web as we speak and henceforth, and that's quite different. And that's just about acceptable to do that. Another example of the internationalization, Jeff Hewitt's talk in 1990 was entitled Chemical Engineering in the British Isles to the Institution. 20 years later, I think that would be an unacceptable title. More recently, Greg Lewin has talked about the boundaryless profession. I think with this double meaning of boundaryless in its discipline base and boundaryless in terms of where it is done. And it is that I believe causes a challenge. To communicate across the world to 7 different countries where we have members, all of whom feel they need to be involved and properly should feel they want to be involved, is really difficult. So I think that's the challenge I want to set myself over the next year, is to understand that, because it's my view that this rapid change we've seen is actually with us forever. It will continue. There will be no diminution. The discipline is growing totally, absorbing new things, getting broader, and that very success, which that is, poses a challenge. So the institution, both its members and its officers, have to be flexible and adaptable. I think it is no longer acceptable, and I think the institution fully understands this, to have people such as myself standing outside the pipeline unable to get in. The institution has responded to that extremely well, but will need to continue to do so. And I would argue, in order to do that most effectively, we have to be exceedingly close to our membership. They are what it's all about. They see it happening day to day. And at the moment, I don't see mechanisms, neither in this institution or indeed any other I'm associated with of a similar kind, of involving the membership in a big enough way to be sure of that. The councils of such organisations need somehow to connect better to their membership. And I'm determined that we should find a way of doing that. But I don't say it is easy, because I think our members are the lifeblood of the institution. How do we connect to them globally? Is electronic means adequate? Should we have some other means? What is the governance of an institution that is based in many different countries? There are many difficult issues around that. So I'm going to try and listen to as many members as possible by finding ways of doing that I hope will set us up for the future. Because I think if I can succeed in that, if we can succeed collectively, then I do believe, just going back to the total title of my talk, we will be able to unlock the potential that's locked up in chemical engineering and has not yet been delivered, and deliver what the institution has set out for itself, the chemical engineering futures. Thanks very much.
Well done, Bill. So I'd just like to say a few words of thanks. I think the world is really confronting a very interesting era in history. We are seeing remarkable change in a globalized society. We're seeing recognition of scarcity. we're seeing a recognition and understanding of sustainability in the media, and the public are looking for solutions. I think Bill has given us a very interesting insight, and it's in the context of a successful institution that has changed much over the last 5 years. And this word balance, I think, is very important. Often we see change involving swings of the pendulum from one extreme to another, replacing one dogma with a fresh dogma. This year we've seen the so-called Arab Spring, and there's a sense of fundamentalism and dogmatism being replaced by pragmatism and balance. And I think in this context, Bill will help bring enormous comfort to the institution with what he's said today, and with his passionate drive to get closer to the membership, perhaps be a little bit more reflective on the way we are trying to achieve a few things, and to ensure that we preserve the necessary balance going forward. So I'd like to once again thank Bill for taking on the challenge of the IChemE and guiding us through the next important phase. Thank you very much, Bill.
Thank you very much. I think the next order of business is to adjourn. You will find in the room from which we came different kind of refreshments this time, perhaps to recover from the talk you've listened to. So thank you very much for your attention.